Ladies and gentlemen, my name is Marko Höyhtyä and today I will talk about 6G and satellite communications from the military perspective. I'm working at the Finnish National Defence University as a professor of technology adaptation, studying how emerging and disruptive technologies like quantum tech, space, 6G could be adapted to military needs. Before my current role, I spent 20 years at VTT, Technical Research Center of Finland, last years as research professor of satellite communications. I have published 2 books about SATCOMs and founded a company to work in this exciting area. And I also hold the position of docent here at the University of Oulu. I have had a couple of international visits. Last one was at the University of Bologna, 23. And my recent book is visible in this slide, and part of the material that will be presented in the coming slides are based on the book. So on the left-hand side figure here, you see the number of satellites launched annually to low Earth orbits since the first ever satellite Sputnik 1957. The decades until 1990s were dominated by military systems, as visible in the figure. However, during the last few years, commercial systems have been very rapidly growing, and as of today there are already more than 10,000 satellites in the orbit. And majority of those satellites are SATCOM satellites in low Earth orbits. As of today, all military forces use commercial satellites as part of their operations. Okay, so the satellite system architecture is divided into 3 main segments. In the space segment, you have satellites themselves and the links between those. In the ground segment, you have the satellite operator part, so you can control the satellites and monitor the status of them using telemetry tracking and control stations. And from the network operator side, you have the gateway device that connects the satellite system and links to the terrestrial network. And then finally in the user segment, you have the actual end user devices like mobile phones or flat panel antennas on the roof of cars and airplanes and so on. The satellite itself consists of multiple subsystems. The most important part of the satellite is the payload. That is the reason why the satellite was designed, built, and launched into orbit. All other systems in the satellite are there to support the operation of that payload. For example, you have temperature control, you have attitude control subsystem to keep the antennas oriented towards the Earth, and propulsion subsystems to do the orbital corrections and sometimes collision avoidance procedures. All military forces use commercial technologies in their operations. Maybe you have heard about the term dual-use technologies. 5G is one of those techniques. It brings high transmission rates to the communications, and it includes many interesting features that have been designed for public safety communications, like network slicing, prioritization. Also multi-antenna techniques are very useful in military domain. However, 5G has mainly been urban technology, not very good in remote areas, and the end user devices are easier to detect and jam compared to military radios. Now, very interesting development is ongoing in 3GPP standardization, where satellites are now becoming a key part of future mobile networks. This is called non-terrestrial networking, and it has been estimated that this market size will reach 100 billion euros annually in less than 10 years. So what is the reason that 5G and 6G systems would include satellites? The motivation is given on the right-hand side. So the satellites, they will bring in ubiquity, capacity all across the globe. You can have the connections in every area, even there where it is not feasible to build terrestrial networks at all. Then you will have mobility, support for all mobile platforms, whether they are in the air, on ground, at sea. You have the capability to deliver the content simultaneously to large areas by broadcasting. And finally, the resilience part. Even when the terrestrial network is not there or it has been destroyed, you will have the option to communicate via the satellite. Then from the use case perspective, you can think that the satellites will bring broadband capability. Already now you have devices like Starlink where you can reach hundreds of megabits per second downlink speed. Then you have machine type connectivity, IoT services for hard to reach areas. And then maybe the most interesting one now is this direct satellite to device connection, where you could use your regular smartphones as satellite terminals without needing to invest in any additional devices. So the architecture of those NTN systems looks a little bit like that. It is mostly covering the areas outside urban environment. So rural, remote areas. You have satellites in different orbits. In traditional satellite systems, you are using so-called transparent architecture, where the satellite receives the data, the signal, amplifies it, converts to different frequency and sends the same waveform again to the end user devices. Now in modern systems, you can use also regenerative transmitters where you demodulate and decode the signal at the satellite, and then you can use different waveforms when going further. For example, optical ISL links and rerouting of data. When we think about the direct connection between the satellite and small mobile phone type of device, you have now three main options how to do that. Already now there are phones like Apple iPhone or Huawei that includes this emergency messaging using proprietary SATCOM connection. So using, for example, Global Star connection or Beidou connection for emergency messaging. Then in the standardized systems, there are already demonstrations and capabilities to connect using IoT narrowband connection using this standardized technology. And then finally, the full 5G connection between the satellite and the small device, so wideband transmission, where it is required that the satellite has very high gain antenna to reach and to be able to close the link between the small device and the satellite. And this is already demonstrated well currently and will be happening in the future. Also, there is so-called RedCap or reduced capability technology, where more energy efficient option of 5G, still wideband, could be implemented. And this is, for example, studied by VTT and University of Oulu here in Oulu area. Now looking at the military use of those satellite systems and 6G. For your information, NATO has identified commercial space tech and 6G as potentially disrupting ones, meaning that they can disrupt the way military operations will be conducted in future. Starting now from the current situation, the most important commercial space system during the Ukrainian war has been the Starlink. Already in September 22, there were 23,000 Starlink terminals in Ukraine, 150,000 daily users of those terminals, and the number has increased steadily since then. It has provided means for civilian and military people to communicate, access international news, provide up-to-date situational awareness, command and control for artillery, barrages, and so on. And very interesting way to use it has been to attach the terminal to drones. So on the right-hand side, down there you can see those Magura Ukrainian kamikaze drone ships loaded with explosives there is Starlink terminal in the back and camera, and then the detonator in front, so that they are then driven with full speed to hit the adversary ship. And actually it has a very big effect in reducing the impact of military ships during the war. Another interesting case is to look at this bomber drone. It is a multicopter device that can carry a bomb, and when those kind of devices are used with terrestrial radios, they are easier to jam from the ground. But now when having the Starlink antenna on top of that kind of drone that communicates with very highly directional transmission between the satellite and the drone, it does not care so much about the jamming from ground, and that's why you need to have also jamming devices in the air to really have an effect on this device, which means that it is more challenging and not so easy to do. 6G will now disrupt the network architecture. Until 5G, the networks have been optimized to operate very well on horizontal domain, close to the ground. And now 6G will add this vertical dimension, making the network three-dimensional, enabling communications and positioning everywhere. So you have now these airborne and space components as well included. The left-hand side figure is our own vision few years back, and now what is happening in reality is that Europe is investing 10 billion euros to build this kind of multi-layer system called IRIS². And this visualization prepared by satellite operator SES shows that there are a couple of hundreds of LEO satellites in addition to satellites in higher orbits, and then that it's integrated together with terrestrial network to provide services for critical users like public safety and military. 6G will bring new use cases compared to 5G. And as mentioned already, this remote area connectivity is a very important one. It is the design criteria from the beginning, enabled by SATCOMs and also low-frequency terrestrial communications. Then you have integrated sensing and communications capability, meaning that your communication signals can, for example, be used to gather information about your environment. And finally, there is a combination of artificial intelligence and connectivity. So the network functionalities will be AI optimized, and the network itself supports much better distributed computing applications like joint operation of autonomous devices in different domains in military scenarios. So what are then the military use cases that could be enabled by 6G? This figure is based on the quite recent publication from the Finnish National Defence University that is in Finnish. Starting from number one, it is a no-brainer that the network needs to provide connections everywhere where soldiers go. So remote area connectivity is a very important feature of 6G systems. Inclusion of satellites as part of those systems makes it much more interesting from the military perspective. 6G and the LEO satellites will provide also new positioning, navigation and timing capabilities. So it can complement current GNSS systems and add resilience when those frequencies are jammed. And this accurate 3D positioning for very high mobile targets can mean that the technology could be used, for example, for smart ammunition. Joint sensing and comms, better situational awareness picture. Then using immersive tech and AI, maybe it is possible in the future to create distributed training environments where people from different locations can come together, train in the target environment before their operation, and then physically gathering to do the duty. So cost-efficient way to prepare to do things in reality. Then finally, all the battlefields are becoming transparent, meaning that there are really huge amount of electromagnetic emissions coming from different devices and sensors as seeing humans and so on. In the past, the idea was that we want to hide all the transmissions and we don't want to emit anything so that we will not be seen and we will not be attacked. But now the new paradigm could be in a way that in a hyper-networked environment, we don't try to hide, but we just want to create so many emissions that look similar in the spectrum that it makes it too challenging for the enemy to decide what of those targets to shoot. And especially if they have similar radio fingerprints, like cheap sensors and more expensive targets, it makes it really, really challenging. And it is not wise to spend very expensive missiles to hit cheap sensors. So 6G and satellite communications will provide very interesting capabilities for military use, and there will be for sure many inventions to come in the coming years. Thank you very much for listening.